problems I solved in graphs. I think it's easy if I can. So I started with my DFS, simple DFS. Then we have the multi source DFS, right? So in a for loop, if the node is not visited, then call the DFS function. Similarly, the BFS also, multi-source BFS. For multi-source BFS, we have the shortest path with equal weight edges kind of problem. After multi-source BFS and DFS, what did I learn? I think coloring of the graph, two coloring, or the bipartite check. Bipartite checks. Also did the cycle detection in the graph. Cycle detection. So for two coloring or bipartite check, what did I do? If I have a node which is colored as 0, its neighbors should be colored at 1. So this neighbor should be colored at 1. Let's do this time. So this node is colored with 0, its neighbor should be colored with 1. From this neighbor, if I go to a node which is already colored with a different color, that is fine. But if I go to a node which is already colored with the same color, that means it cannot be a bipartite graph. Yeah, two coloring cannot be performed on this. For cycle detection, I have two kind of things. One is on the directed, one is on the undirected. Undirected was easy. I think if I visit a already visited node, that means there is a cycle. It can be done using BFS or DFS, both. For directed graph, what did I do? I had to maintain a boolean vector in stack. So every time I visit a node, I push it in the stack. Every time I'm done processing that node, I remove that from the stack. So let's say if I'm going down, and from here I get an edge which is pointing to any of the node that is inside the stack, that means there is a cycle. But if it is done, if I'm done processing this node and this edge was not there, that means there was no cycle, and this was pointing here, so it is not inside the stack. Yeah, so this vector covered. I think in Tarzan's algorithm also we used this kind of thing in stack. Yeah. So what else? After DFS, BFS, cycle detection and two coloring, I solved few problems on the topological sorting. After topological sorting, yeah, it can be done using BFS or using the DFS. I think DFS one was much simpler. I just, when I'm done with the processing of the node, I push it in the ordering vector. So that was DFS. For BFS, I think, yeah, so for push every node which has the degree of 0 initially in the queue, and then from that go to all the neighbors, decrease their degree. If they become 0, then push in the queue and process them. So it was also easy, but a lot of code. I would prefer DFS one for topological sort. For after topological sorting, I think I solved on the Kusaraju SCC finding, strongly connected component of the graphs. So Kusaraju algorithm also. So how did we do it? So this thing. So first run a DFS, first find the topo sort of the given graph, and then in that order only, the topo order only, run in the reverse graph, run the DFS in the reverse graph. So every time a component is extracted, so that belongs to one SCC1, so this belongs to SCC2. Yeah, Kusaraju uses two DFSs, one on the graph adjacency and one in the reverse adjacency. After Kusaraju, I think I did some problems on the LCA finding, right? So for LCA, I had created the sparse tape, a binary lifting kind of thing. Binary lifting. Yep. The lowest common ancestor or the path between any two nodes, these kind of things. After this, so LCA is simple. After this, I solved the problems on DP on trees. So I think we had few problems. One where I have to find the in kind of DP, one where I have to find the value of the parent, one where I have to find the value of child, then that is in kind of DP. This is out kind of DP. I think one problem for this was the diameter problem, right? Or the size one, I think I solved. That was the longest video. Yeah. So that was also good question on the DP on trees. What else? After DP on trees, we solved LCA. I think, yeah. Shortest path problem also. Shortest path. I think I solved the Dijkstra. Dijkstra could not handle the negative edges, so we solved the Bellman-Ford. And Bellman-Ford, if I want to find all pair shortest path in n cube, that is the Floyd-Warshall. Some variations on Dijkstra also I did. So like how many ways are there to reach the destination node in the shortest amount of time? So that question, or in the graph or in the matrix also variations. In the matrix and adjacency vector. Once the shortest path is over, I solved the question related to the DFS tree of graph or anything else. No, I think LCA and DP on trees and shortest path in DFS tree of graphs. I think it started with the DFS low linking. So that found the bi-connected components, or two vertex connected component, two edge connected components, or the articulation point and bridges. So these kind of, I think I need to revise these things. These are clear. So this was for the undirected graph, and DFS low linking was also used for directed graph to find the strongly connected component, which was the Tarzan's algorithm. And once we find the strongly connected component, we can also create the meta graph of that. I think last problem I solved was this only. For the meta graph, since it is a directed acyclic graph, it can have questions on DP also. Yeah. Then DFS on trees, we need to revise the two vertex connected component, two edge connected component, and bi-connected decomposition kind of thing. Yep. I solved this, how to find the center of the tree, how to find the centroid of the tree. So these kind of things. Yep. I think the only major thing remaining is the spanning trees. The spanning tree can be maximum spanning tree, minimum spanning tree. For minimum we have the Prim's, and for Kruskal is similar to Dijkstra, and Prim's, for Prim's we need to use the DSU. Yeah, I think this question I need to do on the spanning tree. Okay, I'll do it next. What else is remaining in graphs? DFS is done, BFS is done, multi-source BFS, shortest path, two coloring bipartite check, cycle detection, directed and undirected using in stack, and visited BFS DFS. Okay, topological sort is done. Cursor Azus algorithm is done. How to find the LCA is done. DP on trees is done. Few variations, diameter, size, this kind of question. Then shortest path, Dijkstra, Bellman-Ford, Floyd-Warshall, this kind of thing. And then DFS trees and graph, DFS low linking, BCC two vertex component, two edge connected component, articulation point, bridges in the undirected graph. For directed graph, I think the Tarzan's algorithm was important, creating the metagraph and then DAG and then DP on that. Center and centroid, spanning tree, the minimum maximum spanning trees, prints and crucicles. I think this is the major remaining thing. After this we can solve some advanced topic, but I'll do that later. Okay.